So in this video I want to talk to you about bond angles versus dihedral angles. Now bond angles are something you're probably already familiar with, particularly if you're taking organic, because you already talked about Lewis structures. And Lewis structures in the general chemistry sense, we probably gave you simple molecules like tetrahedral, octahedral, all that. And we talked about the bond angles. Now, I'm not the type of instructor that requires students to memorize bond angles, and the big reason I don't is that unless all the atoms are exactly the same, these ideal angles are not what's seen in practice. But let's go back to it anyway. So what I've drawn here are two different conformational isomers of butane. Now, what I haven't drawn in are the hydrogens, because typically we ignore those in line bond drawings, but let's just draw them in right now on the second carbon. So a bond angle is defined as the angle between two bonds, ergo bond angle. And for most carbons, particularly those in sp3 hybridization or tetrahedral, it is 109.5 degrees. So a bond angle refers to the angle between two bonds. The one you're probably not familiar with, though, is dihedral angle. And to understand the dihedral angle, what we're going to need to do is draw the Newman projections along these bonds. So if I look at this compound, as drawn, I'm going to put the CH3 group down. It gives us a hydrogen up, hydrogen up. This would be our Newman projection looking along this bond. Now if we draw this one, I got a little happy with methyl groups. This would be our Newman projection. So dihedral angles actually refer to the angles between bonds that are separated by another bond. So in the case of this compound, the dihedral angle between the methyl groups is 180 degrees C. Now to define a dihedral bond, we have to kind of describe, because we've got things separated by an atom, we also need to specify what we're talking about. With a bond angle, it's easy. It's two atoms connected to a single atom. In this case, we can describe the dihedral angle of the CH3 groups relative to each other, or the hydrogen CH3. So in the case of the hydrogen CH3, the dihedral angle here is 120 degrees, or this back hydrogen, that's the hydrogen in the front. The dihedral angle between the methyl group and the back hydrogen here is 60 degrees. So to define a dihedral angle, first of all, we have to talk about what we're talking about relative to each other. So if we're looking at the hydrogens relative to this methyl, or the methyl relative to this methyl. Basically what it is, if you were to draw it out visually, which I'll try to do here, we have our methyl group up. We have two planes here. The first plane is from this methyl group carbon and this carbon. The second plane, and I apologize to you, those of you, well, I gotta find mine. Second plane is created by the methyl group and the two atoms along the common bond. The dihedral angle is the angle between those two planes. So a couple ways you can look at dihedral angle. Me personally, I look at it as the planes and the angle of those planes, or in terms of your Newman projection, is the angle of those groups relative to each other in the Newman projection. Regardless of, this is how we find the dihedral angle, and this is what we're talking about when we describe a dihedral angle.